Hello to everyone and welcome to part 5 of this video series. So for the part 1 to part 4, I'm going to put a link in the description box which were differential equations for the past years for 2017 to 2021. So for those interested in getting the video, I'm going to put a link in the description box and also as a card above here for those really interested in getting it. So now we're going to be answering 2016 in this equation in this video, and 2016 says that given that y equals to ax e to the 2x is the particular integral of the differential equation d squared y over dx squared minus 4 y equals to 8e to the 2x, find the value of the constant a. Now we have been given our particular solution, so we can simply say our y particular is a x e to the 2x. Now to get the complete, in fact there's no need looking for the complementary solution here because our particular solution has been given to us. So what we might do is we look for the first derivative here. So this implies that our first derivative dy all over dx will simply be equals to a e to the 2x to the 2x plus 2ax e to the 2x, and our d squared y, so we're going to call that equation 1, and we'll call this our equation star. So our d squared y all over dx squared will simply be equals to, now here we're going to have 2a e to the power 2x now plus 2 into a e to the power 2x plus 2a x e to the power x. So if we simplify that, we're going to have 4a e to the power 2x plus 4ax e to the power x. So there is a 2 there, there's a 2 there, and there's a 2 there. So now we have this is our equation 2. So if we go back to our equation star, we see that inputting d squared y and dx squared, we're going to have 4a e to the 2x plus 4ax e to the 2x. Now we have minus 4y, so minus 4, our y is ax e to the 2x, so this should be equals to 8e to the 2x, so 8 e to the 2x. Now we notice that our e to the 2x is common, so it's going to go out, so e to the 2x is going to go out, so our 4a ax will also cancel out, so we'll be left with 4a equals to, we'll be left with 4a equals to 8. Therefore this implies that our a is 2. This is very clear and good. It's very clear and good. So we have our a. Therefore our y particular will simply be equals to 2x e to the power 2x. That's our y particular. Now going back to the equation, the equation says the value of a, we have gotten the value of a, we have gotten the particular solution. Now they said the general solution of the differential equation. Now to get our general solution, we know that y general should be y complementary plus y particular, but we see clearly that from here, if we from here we see that this is n squared minus 4 equal to 0. So this implies that our n will be equals to plus o minus 2. So n1 is 2 and n2 is minus 2. So it's very clear, minus 2. So our complementary solution will simply be, since there are two real and distinct roots, then our general solution will be equals to 2x e to the 2x plus a e to the 2x plus b e to the minus 2x. So basically that is it. Okay, now that's our general solution, but we're given some conditions to look for the particular solution of the differential equation. Y was 1 and the y on the x was minus 8. So we know that our y is 1, our y is 1, y is 1, and our dy all over dx is minus 8, and x is 0. So we're going to first of all use this and this to get one of the solutions. So if we put 0 here, so we are going to have now our y will simply be equal to 0, right? Y is 1, so we have 1 to be equals to 0 here. So we have 0 here plus a there plus b. So that's our equation 1. Now we're going to differentiate this function. So when we differentiate that, we are going to look for dy dx to give us the derivative of this function will be 2e to the power 2x, 2e to the 2x plus 4x e to the 2x plus 2a e to the 2x minus 2b e to the minus 2x. So we know that our x is 0, right? And our dy dx is minus 8. So we have minus 8 should be equals to, so we put our 0 there, we're going to have 2 here, 2 there, plus 2a and minus 2b, so that we have minus 10 to be equals to 2a minus 2b, which implies that we have minus 5 to be equals to a plus b minus a minus b, a minus b. Now this is our equation 2. So now if we add these two equations, we'll see that we have equation 1 plus equation 2. Equation 1 plus equation 2 means that we'll have minus 4 to be equals to 2a. This implies that a is equals to minus 2. That's our value of a. That's our value of a. Now, if we just take the value of a and substitute in any of the equation, we're going to get the other value of b. So from equation 1, a is minus 2. So from this equation, if a is minus 2 implies that 1 to be equals to minus 2 plus b. Therefore, b should be equals to 3. b is 3. b is 3. Therefore, coming back to our general solution, y general will simply be equals to 2x e to the power 2x plus, now our a is minus 2, so it will be minus 2 e to the power 2x, and our b is 3, so it will be plus 3 e to the minus 2x. Okay, so that is our solution. That is our solution. Okay, thank you guys very much for watching to the end. For those interested in getting more videos, you can subscribe to this channel so that whenever I upload new videos, you'll be notified. And if the video was helpful in any way, you can give me a like, and I'll see you in the next video.